Hello everyone. So this is my teaching demonstration video. The topic is basics of crystallization. So what is crystallization? So crystallization is a physical transformation of a liquid, solid, gas or solution into a solid particles in a uniformly arranged molecules. So these are the few images from my PhD work of crystals. So there are different types of crystallization. So the first, these four are the solvent based and the non-solvent based. In solvent based, the first is the cooling crystallization. So when we cool a solution, the crystals are formed. And second is the evaporative crystallization. When we evaporate a solution by providing any external temperature, then the crystal forms. And the third is the reactive crystallization. When we mix two different medium, and because of that, the crystallization occurs. And the fourth is the anti-solvent crystallization. So when we add any secondary solvent other than the primary solvent, which react with the solute present inside the solution, and the crystal forms. Then the next is the non-solvent based melt crystallization. Here we melt the solute beyond its melting temperature, and because of that, the crystallization occurs. Then why do we need of crystallization? So crystallization need in like various industries for purification of solids, separation to achieving the specific polymorphic form of any crystal to produce specific products, high quality products, and also economic impact. There are various factors which affect the crystallization, like solute properties, types of solvent, seeding, impurities and additives, temperature profile, mixing and flow rates, supersaturation, which I am going to talk in the next slide, crystallization vessel. So in industry, crystallization is used in various uh, sectors like pharmaceuticals, nutraceuticals, chemical and fertilizers, semiconductor and chip. So in semiconductor and chips, the non-solvent base that melt crystallization is used. So this is the schematic of a lab scale crystallization. So from a solution, the crystals are forming. So this can be by cooling, evaporative, anti-solvent, or reactive. So these are the basic steps of crystallization: supersaturation, nucleation, crystal growth, filtration, or harvesting. Supersaturation is the most important part of the crystallization. So when the solution is supersaturated, and then the crystallization occurs. And so if the value of supersaturation, that is S is equal to 1, then solution remain at a steady state. And when the supersaturation is more than 1, then uh, it starts crystallizing. And when the supersaturation is less than 1, then it is undersaturated. So in that case, no crystal formation takes place. And supersaturation can be calculated with the formula S is equal to C by C star. So here C is the solubility of the solute, and then the C star is the solubility of the solute at that specific temperature at which we are going to crystallize that solution. The next is the nucleation part. So nucleation occurs. Nucleation is the phenomena where the small tiny particles form, and that phenomena is known as nucleation. So this can be induced by various factors, by providing ultrasonication, by providing seeding, by providing any anti-solvent, and by providing like different temperature and etc. So after nucleation, then crystal growth takes place, and the small particles that form during nucleation undergoes crystal growth, and this grows and up to a specific size or whatever we require for the specific objective. And after that, the crystals were filtered and harvested for further analysis. Then there are two types of reactors or crystallizer. We can say the batch and the continuous. So the first is the batch one. In this one, we can put the solution inside a crystallizer or a reactor, and after a certain time, we can collect the overall product. So this the temperature, nucleation, supersaturation, everything uh, attain inside this one. While in case of the continuous one, so we are continuously feeding the sample solution, and from one end we are getting the product simultaneously. So there are various types of continuous crystallizer, MSMPR. So where we connect the two different CSTR, and from that we can get a specific product or crystal. Then the fluidized bed. So this is a long hollow tube. From in this one, the sample is pumping from the bottom to top, and the beads present in this one, interaction between beads and the solution results in the crystallization. The next is the oscillatory baffle. So this is a long hollow tube, and at specific points the baffle are present, and because of that the crystallization takes place. And another one is the unbaffled one. In this one, this is also a long hollow tube, but no baffle present. But the orientation of it tubing in such a way that that provides the crystallization. And the next is the slug flow ones, where two different immiscible mediums are mixed with each other, and because of that, the slug formation takes place. And the nucleation, supersaturation, crystal growth, everything happen inside that each slug. And after crystallization, the crystals were collected and stored for further analysis. Thank you.